Good afternoon and welcome to the Convergent Science Network Women in Biomed panel. My name is Katrina Ving Nguyen Robertson and I'm a Science Communications Officer for the Convergent Science Network. Before we begin, I would like to acknowledge the traditional custodians of the lands on which we're all streaming from. Hopefully we've got lots of people coming in from different places, but I myself am on the lands of the Wurundjeri people of the Kulin Nation, and I pay my respects to their elders past and present. And I think as people who are interested in science, it's nice to acknowledge them as the first scientists of the lands. In their endeavour to understand the land, the sky and the sea, they did lots of observations and learning, and they still do, and that is what science is. So speaking of science, the talents of women in science, technology, engineering and mathematics, or STEM, are vital to the future of Australia and, to be honest, the world. Yet it's no secret that women are poorly represented in the STEM workforce. So this Convergent Science Network series, the Women in Biomed series, explores the careers of some amazing women in biomedicine. We celebrate their successes, share their research and their experiences. So we'll kick off the conversation. I'll ask some questions of my own, but later I will call on you to ask questions as well. So if you have questions for either of the two speakers, please do pop them into the Q&A box down below and we'll pass them on. And if you'd like to continue the discussion online and share your thoughts as well, please do use Twitter and things like that. Use the hashtag WomenInBiomed and tag us at Conversi. We'll also have a survey at the end that I'll remind you about at the end as well, but we'd love to hear your thoughts on the series. So without further ado, let me introduce our two speakers for today. Today we have Professor Kim-Anh and Associate Professor Jaclyn or Jack Pearson, and both are recipients of numerous awards and fellowships, way too many for me to list, and they're literally superstars of STEM, having been selected as powerful role models for the Superstars of STEM program run by Science and Technology Australia. Kim-Anh is fascinated with numbers and how innovative statistics can influence the world. She is a professor in statistical genomics at the University of Melbourne, developing novel methods, software and tools for people to be able to interpret big biological data and answer research questions effectively. We also have Jack, a microbiologist at the Hudson Institute of Medical Research, investigating how gut pathogens cause disease and how humans fight them. Her research has uncovered highly novel ways that bacterial pathogens try to evade our immune system, which has provided some quite fundamental insights into how we can combat infection. So now I'll hand over to them just to get a little bit of a context as to the work that you do. Maybe we'll start off talking about your research. So Kim-Anh, you are a professor in statistical genomics. What does that actually entail?
Yeah, so as you mentioned before, I mainly work with data, so big data. And so being in statistical genomics means that my team develops methods to analyze those data. So we develop statistical methods, we develop algorithms in order to churn those data so that it makes sense, we can make sense of it. And there's also a big component in my research in applying the methods we have developed to collaborative studies. So we get to work with a lot of biologists as well.
Yeah, so what sort of biology questions are you answering? What sort of questions can you tackle with these innovative statistics and the toolkits you're developing?
Yeah, so I just want to quote one well-known statistician, John Takei, who says the best thing about being a statistician is that you get to play in everyone's backyard. That's really what I do. So I get to work with different types of disease, from autoimmune disease to cancer to, or just biological development, ecology as well. And so really what we're trying to do is gather all the data from our collaborators, and they are data that are high throughput, so they're really big, like you can measure, hundreds of thousands of parameters to describe a biological system or a human. And what we're trying to do is to really try to identify what is the most important information from those data. And so that can be in the form of identifying biomarkers of disease, but it can also be about, identifying what are the genes or what are the metabolites that can explain a particular biological system.
So is it more that you're working with collaborators in biology and they help you sort of take your tools to apply them to that? Or are you keeping all of these sort of research questions in mind as you develop the tools?
A bit of both. So often, all the development we do is driven by real biological question from our collaborators. They come to us and they say, hey, I have this issue. I don't know how to solve it because no one else has solved it. And so in that case, what I do is I actually gather all their questions and try to generalize it to a more generic frameworks that we can answer. But I also work with them once I have the method to say, hey, I have this method. I'd like you to look at the results and tell me whether we're in the right track or not. Is our method actually answering your question?
Thank you. And I do want to talk a little bit more about, the education sort of side of what you're doing as well. But Jack, I want to turn to you. Could you please tell us a little bit about your work in understanding bacterial infections?
Yes. So I work particularly on bacterial gut pathogens. So the babies that I work on are E. coli, Salmonella, and Shigella, but we don't really like to think of ourselves as being limited to those pathogens or those bugs. We like to see ourselves as people who can study those bugs and then apply them to other pathogens as well. So what we really do is we understand how the bacteria causes disease, and we look at very specific mechanisms by which the bacteria do that. And in the past, we've discovered that the bacteria inject their own proteins into our host cells through needle-like structures. It's very fascinating when they're attached to our cells. And this is in the gut. We particularly look at pathogens that infect the gut. So they inject these proteins into our gut and they hijack our immune system. So they can do so many things. They can actually promote inflammation, they can stop inflammation, they can stop cells from undergoing a natural process of host cell death, because our cells can actually die in order to help us get rid of pathogens. But they can shut down all of those processes. So we've actually made a number of discoveries for specific ways in which the bacteria do that. And that's really critical, because the problem with bacteria is that they have so many ways that they cause disease that it can be very difficult to develop vaccines or therapeutics, and they are actually vastly different within their groups. So you can't just say you've got one type of E. coli. There are thousands of types that are circulating around the world globally. So you can't just make a vaccine for one and hope that that's going to be successful. So these pathogens that I work with, it's been very difficult to develop therapeutics and vaccines for them. And I guess the work that we do, it really just kind of plugs into that. How are we going to be able to do this? And so by identifying those very specific ways in which they can target our immune system, and also identifying ways in which we respond to specific bacteria, that gives us a better chance of, targeting either our immune system or the bugs to prevent disease or to treat disease.
Yeah. Bacteria are so tricky, right? As you point out, it's difficult to develop vaccines, and antimicrobial resistance is such a big problem now. Do you think that this greater understanding of the sort of host-pathogen relationship can really help us develop novel therapeutic targets and maybe even repurpose drugs that we already have if we know a little bit more about how it all works?
Yes, absolutely, Katrina. The important thing is that a lot of these pathogens, as you said, are highly drug resistant, and they are only becoming more drug resistant. And the scary thing is that as they become more drug resistant, they can actually become more virulent in that they can cause more serious disease. So this is why it's really critical that we understand the interface of the pathogen, multi-drug resistance or the antibiotic resistance, and our host immune system. And if we can understand that for specific groups of pathogens, we have a much greater chance of taking, as you said, drugs that are already available on the market and applying those to an infection setting, or using those to kind of teach us, okay, well, if we use this drug that's already approved and it kind of lowers the bacterial numbers, how can we then look at the host immune system and say, well, the drug targets this part of the host immune system. Maybe if we look at parts that are connected to that part of the immune system, we might be able to target something more specific than that drug and then, repurpose or redesign one of those drugs to more effectively treat that infection. So it's a big learning game. It's going to take a long time, but we really have to get started now because, as you probably know, antimicrobial resistant infections are associated with up to 5 million deaths per year. And, we're looking at least 10 million deaths per year by 2050 based on a report that came out a little while ago. So it's really critical that we do look at the interface of drug-resistant pathogens and the host immune system, not just these lab-adapted pathogens that we've been looking at for years, thousands of papers published on one bacterial isolate that everyone's been working with for 50 years. So it's important that we look at clinical isolates when we're doing this.
Yeah, absolutely. Such important work. So what does a day of research look like for you, Jack?
Research? I'd like to say I was in the lab like I used to be, but I have, 2 small kids at home and a teenager. So a day for me really looks like, first of all, getting those people out of the house, the little ones, and coming into the office and supervising students and writing grants and writing papers and having meetings. That's what my days look like at the moment. Every now and then I do actually get into the lab because I have specific expertise in models, in vivo models of infections. So I like to get in and do those experiments, and that's really great for me because it means I get to be involved with my students and other researchers. We have very strong collaborations with the Walter and Eliza Hall Institute, and so we're often back and forth doing those experiments. So yeah, I do get into the lab, but most of my time is spent in the office and then rushing off in the afternoon to get my kids. And then after I've got them to bed, I usually sit down and answer emails and get back to my grants or, papers, whatever it is.
It sort of never stops.
Yeah, nope.
Kim-Anh, what about yourself? What does a day at work look like for you?
A day at work, it can be quite diverse. So as I said, I work on statistical development, but also software development. And so this is what I work with my team. We have a lot of collaborations also. So we work a lot outside with other people. And there's also a large part of my work on education. So whether I am teaching courses at the university, but also I'm also training a lot of biologists that are not necessarily in my university. So that can be with online courses or face-to-face courses. So all these, different things you have to juggle during the day.
Yeah, and I was going to ask you about that actually. What was the transition like from being a biostatistician consultant to then being a research group leader in Queensland? And now you're like both a researcher and an educator at University of Melbourne. Like what was that transition in your career like?
I think it came naturally. I think, when you're a young scientist, you think you're going to go only one way. And then you discover that you have new opportunities. I think you discover also a lot about yourself and what you want to do. And I also think that it's in academia, it's quite normal to reinvent yourself every 4 or 5 years. That's always what I joked with my colleagues and friends. Is that we always need something a little bit new. And I think this is what's been reflected in my career is that, I would do something for 1, 2 years, maybe sometimes 4, and then decide that I actually wanted to pursue a specific aspect in my career just because there was this good opportunity, because I had thought about it for quite some time. And then naturally I would just try to find those opportunities. So it was, it's challenging all the time, but it's also extremely exciting to change across those roles.
Yeah, so you clearly, actively made that choice that you wanted to do some education as well and run workshops and things like that. So why train the next generation of computational biologists? Why do you think it's important?
Well, first, it's important because there's a big gap in Australia. And the second thing is biology, as Jack said, is we working in modern biology, and modern biology is a quantitative science as well. So we generate a lot of data And those data need to be analyzed. And I think it's really important that biologists become computational biologists in a way, so that they are able to analyze their own data and make sense of it without having to wait for a statistician who may not have the time, to do that. So I think it's really important for me to train the next generation, because I know it's going to open more doors to them. I know now that if you only work in the wet lab, it's going to be very difficult, because the work, the field is changing. And so we need to be able, when we have the expertise, we need to also be able to support the new, the next generation to transition as well with time, and progress.
Yeah, absolutely agree. A biologist that can do computational biology, definitely a hot commodity in the field. So you've also moved a lot throughout your career, and you talked about reinventing yourself every so often. So you grew up in France, did a bit of uni there, and then you moved to Brisbane, and now you're in Melbourne. How have you felt that all of these moves throughout your career have aided your growth, perhaps as a researcher and as an academic, and maybe even as a person?
I think those moves corresponded every time to some sort of promotion. Mm-hmm. And so it's been intended, and it has changed me as well, because every time you come to a new culture or a new country or a new city, you just discover new things. I think it's been really good for me to understand different work environments. I've been working also as a consultant, so I kind of understand a little bit how the industry is working. And then I've been working as a group leader, as a sole statistician in a whole biomedical institute. So that was also useful to understand what are the needs of biologists. And now in Melbourne, I move more towards a role as a statistician, which is really what my background is. So it's more like home. But in a very exciting and vibrant environment at the University of Melbourne.
Thank you. Speaking of reinventing yourself, Jack, you completely reinvented yourself. You started off as a drummer, touring with the ARIA-nominated rock band Lash. What inspired your career change swap from rock and roll to biomedical research? Did you always have that passion for science, or was it something that you were like, oh, no, actually, I want to do this?
Yeah, I had a big conflict when I was in high school, because I loved science, but I also loved music. I was extremely passionate. And I think I was left to my own devices a bit, because I was at boarding school, 3,000 kilometres away from my family. So it meant that if I wanted to spend my lunchtimes, afternoons and weekends playing music rather than studying, that's probably what I was doing. So I did go to university because I really wanted to do, science or biomedical science. And a couple of years into that, I had an opportunity to sign a record contract with the people that I had been playing with. And so you don't really give up those opportunities when they come along. And it coincided with a time, the start of my third year. I just started a pathology and biochemistry majors, I think. And I thought, now's the time. So I went and did that, and it was really great. I loved it. An opportunity that, you don't often get, touring nationally with big bands and having your songs on the radio and the TV and lots of photo shoots and lots of media. And it was also very stressful. I was older than the other girls, so I was 3 years older. So I was like the mother of the group, and it was pretty full on. So, after 3 or 4 years, it did get quite stressful. We were very young, and the record industry was quite different back then. It's still heavily male dominated, but, we didn't have a great time, I wouldn't say, with making our own decisions. And by the end of that period, I just was a bit frustrated, and my brain was just, craving, I just needed to use my brain like I had done before. And so I started thinking about going back to university, which I did. And I took on microbiology, and I had to go back and do first year molecular biology because I'd missed out on all this stuff. And that was great because I got to hang out with a bunch of young people. And I started microbiology, and I just loved it. I absolutely loved it. And then I knew that's what I wanted to do. So I finished my degree. I did an honours degree. I absolutely loved that. And I loved it so much that I just, I worked really hard, came top of the class, and that was really surprising for me. And a whole bunch of people started saying to me, oh, you should do a PhD. And I thought, oh gosh, I never thought about that. So that suddenly became an option, and I started looking at universities all around the country because I had a really good mark in my honours. So fortunately, I was able to get an APA scholarship to Melbourne University, which was my top choice. And I just happened to choose a lab that was, it was brilliant. It was on its way up. My supervisor, Professor Liz Hartland, was just a fantastic mentor. I was a bit older coming into my PhD, so I was just really dedicated, really committed, and I just had a great project and I had a great time. So it wasn't a hard choice for me to shift. And, sometimes I think about how I miss music and how I'd love to be touring the world, but at the same time, I wouldn't change what I've done for anything. No.
Yeah, just watching your career or reading about it, you clearly are passionate about it, and you kind of have to be this successful. Like your jump from PhD to award-winning researcher to laboratory head, it's kind of been in quite a short time frame, like all of that in under 10 years, right? From the completion. Had you always sort of set out to, like, from the time that you started your PhD, were you like, yeah, that's the goal? Like, what was that progression like?
That wasn't, I didn't have any goal in mind. I didn't actually know or think about what you do after a PhD, to be honest. It was more the academic pursuit of doing a PhD that was really intriguing to me. I thought, being Dr. Jaclyn Pearson, that's going to be great, but I didn't think about it. So I think very quickly within the first year of my PhD, I was publishing papers first, second, third year, and I thought, I see what this is about now. This is about doing, making discoveries, and having an impact. I can actually do work that is unique, and the scientific world, finds it interesting. And, then I started to understand the process. You apply for grants, you could have your own research group. So when I finished my PhD, I kind of knew that I wanted to keep doing research, and very quickly started getting job offers to have my own lab. And then I thought that was a bit frightening. And I to be honest, I don't think I was quite ready for that to happen. And I was a bit resistant internally to that. And I did have a big job interview overseas. I got, shortlisted, and I missed out on that opportunity, but I did get shortlisted, which is great. And that really taught me a lot. And when I came back to Australia, I had some more job offers, and I thought, I've got to do this. And it was the right choice. It was great. I know it was very soon after my PhD, but I was totally ready for it. I'd been supervising students for a long time. I'd published papers, so I felt like I knew what to do.
Yeah, well, I mean, you may have been hesitant a little bit at first, but like you're killing it now. So, well, both of you are killing it at being researchers. But as I mentioned at the start, women are underrepresented in the STEM workforce, and particularly mathematics and statistics. That department or that field is quite male dominated, right? So, Kim-Anh, what's it like being a woman in a field like that?
Well, I think when you are an early career researcher, you don't necessarily notice it. I think this is what happened in my field, and also because I was always in some sort of biological lab where there were a lot of women, and I had a lot of peers who were women like me, so I never really actually noticed it until much later. I think it comes with your career, where at some stage you look around you and you say, oh, there's only men here. There's only dudes. And so it just came to me, but years and years. I knew about the issue, but I just thought it surely doesn't apply in where I am and in the environment I am. So yeah, it's extremely confronting sometimes, especially, when you end up with a meeting and you think, oh God, there's only men around me, and I'm the only woman, and I'm shy and I'm introvert, and I have to say something, but honestly, I can't be bothered. And so it really pushed me to come out of my shell. But I also want to say that there's a lot of men who are supportive of women, and they're the one who also champion us and help us, to progress in our career. And it's been really good, in the past few years to see so much changes happening. So my school of math and stats is the first school who opened women-only position in Australia. And that was quite controversial back then. And when I heard about that position, I thought, I'm not going to apply. It just means that they're just full of men there. Like, who wants to be there? So I didn't apply. And then I waited for a year or two and just to see how it was going. And I was just seeing that they were recruiting more and more women because it attracted so much attention that a lot of women thought, yes, this is the place where, I might feel very comfortable because I know already that it's a supportive environment. And so now I think we went from 7 women to 27 women in the past 5 years or so. So it's a big increase in recruitment of women as academic, so tenure academic.
That's a nice increase. Hopefully it keeps going up, and similarly for other institutions as well, or other particularly tertiary institutions. Jack, well, one of the barriers that women can sometimes face is having to juggle so many things. Like, as you mentioned, you're caring for 3 children, and you mentioned that you kind of have to juggle looking after them with your work. So how do you find that balance of juggling work life and home life?
Yeah, I just noticed I did a bit of an eye roll there because I'm like, every day I think about it, I'm like, how does it happen? You know what? I tell you what, you just do it. You don't even think about it when it happens because, you're so used to being multitasking in this job as it is that putting the children in there just means you have to multitask a few more things. So it does make my days shorter. That I'd say is the biggest impact, is that I can't have those days where I used to come in to the lab at 7 o'clock in the morning and stay until 6 at night, or, stay all night and do an experiment. I come in, more like around 9 o'clock and have to leave at 3:30 to get the kids. So it is tricky, but I balance it with my wife and we just do the best that we can. And it just becomes part of life, and it's not as, I don't feel like it's awful. I just feel like you have to be really on your toes. That's all. And you have to be prepared to do a bit of work at home as well. But, that's totally fine.
It's probably not the worst thing in the world for you, though, in terms of your body not having like 7 till overnight nights.
That's right. Yeah, sometimes I look at my stuff and I think, oh, that was a late night, and I feel bad. But I think, oh, you did those nights where you slept on the floor under the desk in the lab. You've been there before.
Been there, done that.
Yeah.
What about music? Do you still manage to keep that up on the side?
A little. So we have a little group here at the Hudson that we've done a few things with, which is really nice. And so I do like to keep in touch with it a little bit. It's tricky. You don't have a lot of time to do it. And I am in touch with my previous band members, and we are discussing getting together to do something. So it's always there. It'll always be a big part of my life.
Awesome. Speaking of big parts of your life, I know, Kim-Anh, you're Vietnamese in terms of your background, and that's obviously a big part of your life, but you grew up in France and then you've moved here. Have you found that there have been any language or cultural barriers, like in terms of your career, with having that Vietnamese background and then that French upbringing and then moving that to Australia?
Yeah, huge culture shocks all over. Because I moved, from France to Australia. But even before that, I actually lived on a tropical island. It's in the Indian Ocean. So this is where I spent most of my childhood and teenage years. And then I moved back to the mainland, but without my parents. And I think just moving always, it's been quite challenging for me, because every time you have to adapt to a new culture. And I think you sense also some sort of resistance, internal resistance about, why do I need to fit in? And am I going to lose my identity? And then, of course, when you have the language barrier as well, it becomes even more challenging. But it's also a richness. I think, being able to have different cultures and to understand different environments makes you very agile. So I think when I arrived in Australia, I mean, my English was okay, but my writing English, I was quite concerned about. And I remember writing one of my first grants, and I sent it to one of my mentor, who is not in my field, and he said, I don't know if it's a language issue or I don't know if it's a discipline issue, because he couldn't understand anything. He couldn't understand the statistics or I don't know, I think it was the grammar. But he couldn't even tell what was the issue. And so it made me extremely self-conscious, to be able to write as well as a native speaker for grants that are so crucial in a career was probably one of my biggest challenge. And I had to work hard on it. I think, it's not equitable for everyone. I think, I would talk to a lot of people who are not English speaking natives.
But as you point out, communication is so important, like, for applying for grants and things like that. And your sort of area is so interdisciplinary. How do you find science communication, like speaking to mathematicians, speaking to biologists, and kind of trying to bridge the gap between?
I think in the end, I realized that I didn't need to be sophisticated or articulated. I just needed to get my ideas come through. And often that comes with very simple sentences. So after a while, I realized, I just don't need to, be so worked up on those issues. And yes, so my job is really to work at the interface between different disciplines. So I can talk to a theoretical statistician and say, oh, hold on, let me explain to you what I understand so I can explain it to a biologist. And that's really my job. I see it as just working at the interface and trying to make all these disciplines work together, knowing that they don't use the same language. I mean, they all speak in English, but they still don't use the same language. And there's this acclimatization that needs to happen between the different parties.
Yeah, absolutely. So, Jack, do you use much in terms of like science communication? I mean, we all use communication, right? But do you have much experience in talking to people in different fields and maybe, public engagement and things like that?
Yeah, I mean, for starters, I had a lot of experience before my scientific career speaking to the media with the band. So we had a lot of training, and that was being put in front of cameras and microphones all the time. So from there, I had a certain, I guess, I just wasn't as nervous in those situations, and therefore felt a little bit more comfortable about getting a message across. But then it had to be about science. So I had to learn how to articulate my science in a way that the general public or even other scientists could understand. And I did have some training to do that throughout my PhD. And I found that to be absolutely critical, that training, because they sit you down in front of journalists, and if you don't have their attention in the first 1 minute, they just tell you, I'm bored, I don't understand, I don't know what you're saying. And that's quite a shock, and you think, oh gosh, okay, how can I get my message across in a more simple way? So they were really key to me being able to learn how to communicate my science. And then I think being invited to give a lot of early career research seminars, to tell people about my career, that really helped with my science communication. But like Kim-Anh, I have to talk to a lot of different researchers as well. So I do a lot of cross-disciplinary research, and trying to talk across fields I find to be really interesting. They need to understand your question, and you need to understand their methodologies to a certain extent so that you understand how and why they're applying those to your research. So, yeah, it's something I really enjoy, but it's still something that can make me very nervous as well.
I just wanted to add as well that it's not just science communication outside your lab. It's within your lab too. I think, sometimes we think we are expert within the lab and that everybody should understand what we're doing, but they don't. So even having this science communication within your team is really important.
Yeah. I totally agree with that. Yep.
Yeah. Thank you. Just a reminder to everyone on the call, you can ask your own questions of Kim-Anh and Jack just by popping your questions into the chat, or not the chat, but the Q&A function that's down below. They're on Zoom. But I'll just ask another one as maybe some questions from the audience filter in. Some people in the audience are probably looking perhaps for a little bit of support, or they're looking to see, who are my role models, or who should I get as like a mentor? And Jack, you spoke to the fact that Liz Hartland was an amazing mentor for you. So I just wanted to ask the two of you, what do you look for in a mentor? Like, what sort of support do you seek? Maybe we'll start with you, Jack, and then we'll go to Kim-Anh.
Yeah, sure. I think the first thing you have to have with your mentor is trust. And I think finding someone who can show a degree of kindness is really important. And, maybe that does not necessarily have to be a gentle, soft, cushy female mentor. I have a lot of fantastic male mentors who are just genuinely kind and genuinely considerate, and they really want to help. And so I think, you just have to find that person who thinks that your work is great or believes in you, and keep the lines of communication open with them. Don't just leave it all up to them to, ask how you are or whatever. Step in and ask for some advice regularly, and, talk to them about your progress, and they'll see that you're really keen and really engaged. So the people that I've kept as mentors over the years have consistently been there as referees for award applications or anything like that. And for big and difficult decisions, I can always just, send them an email and say, can we catch up for coffee? And they're always very willing to do that. So, yeah, a bit of kindness, a bit of compassion, and, someone that believes in you.
Thanks, Jack. Kim-Anh, what about yourself?
So for me, I think I have different types of mentors. And I think that's something really important as well, is to define mentor. You have different types of mentors. You can have your peer mentors, and then you can have mentors for different disciplines. So for me, I was looking for mentors more in software development strategies, about how you develop a product, for example. And then you can have mentors more on your career. You can have mentors more on your research directions, and so that's why you often have a lot of different mentors for all these different topics. I think it has to be organic. It's some people may say, oh yeah, go and talk to this person, and it just doesn't click. So it has to be kind of a very natural way, where you start to engage with a person, you really like what they say, and they also seem to appreciate you as a person, before you can move to the mentorship relationship. And I have, as Jack says, I have kept some of my mentors for quite a long time, and they still follow me now. So that's really nice to know that there are people who can champion you, who can help you for applying for awards, because you always need referees of different style in your career. So yeah, I think and they are inspiring people. I think that's what really I'm looking for in a mentor. I sometimes I don't even ask them specific questions. I just want to have an update about what they do. And I'm like, wow, I had no idea you could do this and that together, and how do you juggle? And so sometimes you can approach a mentor because you have very specific questions or concerns, but you also need to ask yourself, what is the benefit for them to be your mentor? And often the benefit for them is, first, they get to learn, in a way, get to learn about a different field or a different approach, or how you approach a problem. But they're also very interested in your career progression. They want you to progress. They see the value in you, and they just want to see how you're progressing along the years as well. So, yeah, think about, what is the value you're also adding to the relationship.
I just want to say I really agree with you, Kim-Anh. That's a lot of my mentors, I actually do work with them now, so I can provide my skills and apply them to their experimental models, and they really appreciate that. And I think that's part of what works. And I cannot agree more with, that organic transition for, finding a mentor. That is how I've found mine, and that works really well. I find it very difficult, the idea of, being paired with someone. However, I do understand that in some situations that is what needs to happen. And, that if that works, that's great. But if it doesn't, don't give up, because there will be someone else who suits, you and your personality. And sometimes the mentor is like 3 steps away. You might know, a postdoc that knows someone that knows a lab head that knows, a director of a company, and you end up really getting along with the third person along that you were introduced to. So there are many different ways, but, if you see someone and you feel inspired, go and talk to them, and they'll really appreciate it.
If you see someone and feel inspired, I feel like these 2 women right here, inspirational. So we're starting to get a few audience comments and questions. One audience member points out that there's this sort of discrimination that's holding back half of the human population, women, and that's really affecting all of us. So part of the question is there anything more important than ending this? But also perhaps you might have 1 or 2 solutions to perhaps getting more women into biomed specifically. So maybe Kim-Anh, we'll start if you'd like to comment.
Can you repeat the question?
So perhaps I'll just sort of rephrase it to think of it a little bit more positively. How might we be able to get more women into biomedicine?
So it has to somewhat come from your institution. I think you need to be in a supportive environment. If that supportive environment is not there, you have to create that supportive environment. You have to be loud, I think, and you have to, be able to talk to, the director, the head of school, and say, look, there's a problem here. Like, why aren't there so many women here? We need more women. You need to be, I think, quite bold as well, and sometimes, say, why are we hiring? How are we evaluating or selecting applications? Is there a bias there? I think you need to really raise those issues sometimes, because there's this unconscious bias, and yet I think just talking about it, not necessarily in an aggressive way, but just making people realize that it's an issue. Can change a lot of things, can change a lot of how people behave, and that can influence, how many women we have. I think it's really important to have women leaders in your institution, because they're the one who tend to then create these new environments. They tend to inspire other women, other young women, who think, oh, okay, I could do that too. I mean, if she can, I can. So it's really important to have these role models around.
Thanks. Jack, do you want to add your comments as well as to, how we might be able to get more women into biomed, or like at least break down some barriers?
Yes, yeah. Well, I think we all know that there's a lot of, females that do undergraduate researchers in biomedical science. And then once we start to move towards postdoctoral positions, and then I guess, senior postdoctoral positions, lab head positions, and then, professor, these start to wane. And there is a lot of reasons for that. And they are traditional reasons, that women have children and they go on maternity leave and they find it difficult to get back to work, and to be able to commit the amount of time to work that some of their male counterparts might. So I think it's really important to put some direct measures in place, and I think very simple things such as having quotas around, if there are seminars at your institute, then we should put quotas on and make half of them women. And I think it's really great to see now with the investigator grants that they are looking at equality across those grants a little bit more. We must start putting direct measures in place to address this. Otherwise, it's just going to take a very, very long time to achieve, equality. So, and like Kim-Anh says, the more female leaders that people see, the more younger people are going to say, well, I can do that too. And the more trust that everyone has in those female leaders. I mean, there are exceptional female leaders around the globe. And they are a perfect example of how competent and exceptional women can be, especially in biomedical science.
Absolutely. But I guess, if you have fewer female leaders, and then you have all these people coming up and they're looking for role models, they're looking for a mentor. Someone's asking, like, how difficult is it to find a female mentor, especially if you are female? Maybe Jack.
I haven't found it specifically difficult because I those female leaders stand out to me. I notice when they're giving talks at conferences, or if they're in the news, in the media, and then you think, oh, that person, what a great set of achievements, and so then you're kind of drawn towards those people, and they can become your mentors if you happen to be able to come in contact with them. So I think around us in the workplace there are just as many female mentors available as there are male mentors, and I've got a mix of both. I've probably got more male mentors actually, and that's just the nature of those people that I was just drawn to those people, and they have been really great. I can understand in some fields of science, some biomedical science or STEM, that it would be very difficult to find those mentors, but it's also good to look outside your field. I think having a mentor that is in another field is probably even better, because they're not stuck in the same old trains of thought that the people around you are, and they can give you really inspirational confidence and information that you might not have got from those people directly around you.
Thanks. And Kim-Anh, I think you started to answer as well.
I agree with Jack. I think it's fairly easy to find female mentors, also because they're aware of the issues that we face as women, and they will be more likely to mentor you. But it's important also to have male mentors. I think it's important. It doesn't, the gender here doesn't really matter, because there are people who need to champion you.
Mm-hmm. We have a question that's, quite different and perhaps on a little bit of a tangent, but I would like to get both of your thoughts. So someone's asking about, perhaps the next pandemic or another pandemic that's coming. And given that we've got, a microbiologist as well as someone who looks at, lots of big biological data, I thought perhaps you might have some interesting viewpoints. So the question is, do you feel like we need to do more to prevent another pandemic, or what sort of measures would you put in place to either protect us from, or just at least be prepared? Perhaps Jack, will start with you.
Yeah, I think that this is an interesting question, and I've spoken to my wife about this because she works in pathogen genomics and was involved heavily in the COVID-19 response. And we talked about what would happen if there was another pandemic, and do you think we'd I said to her, do you think we'd respond better? And she said, I'm not sure that we would. And that's probably because we do have a lot of work to do in pandemic preparedness, but not just within individual countries, but linking, research groups and labs globally. And I think that's really important. Sometimes, and you have countries that don't have as much resources, and if they're not supported as other countries that have more resources, then how are we going to have a better response if we don't address those things? So these are big issues. They're not just small things. But, global connection, global collaboration, supporting countries that don't have, as economies that are as strong, I think they are absolutely critical. And setting up, global hubs for pandemic preparedness is really important. But getting the experts into, big groups so that they can do their jobs really well, genomics experts, infectious diseases experts, statisticians, bioinformaticians, and getting them to work on a more global scale, I think is really important.
Thanks, Jack. And Kim-Anh?
I think my feeling is that we would be more prepared. There are new centers for infectious disease, just because we realize, oh my God, there's a gap here. But I think also because it really, the COVID-19 also taught us that science was important. And suddenly we would hear all about science, and then people will finally understand that, yes, science is, sometimes we don't have the ground truth. Sometimes we get it wrong, and, it's always evolving. And I think it was very good for, just the general audience to understand what science was about. And so it feels like there will be more scientists as well coming on board, more young people wanting to be scientists. And I think what was really interesting with COVID-19 is that it really showed the power of data, because everybody was trying to analyze the data one way or the other. And I just remember the early days where we had these epidemiological models that were so boring. They were all the same. And I was thinking, what are they doing with those data? And I'm not an epidemiologist, but I could just tell that we were just applying those mathematical models that were not relevant for the crisis we're experiencing. And I think now it's really good to see the progress that has been made in terms of modeling, in terms of using data, in terms of sharing data and working collaboratively. So I'm kind of, optimistic that if there is another pandemic, and I hope there is not, but if there isn't another pandemic, we'll be much more prepared based on what we've learned.
Yeah, and I think just to add to what Kim-An's saying, I definitely agree there. I think that, the COVID-19 pandemic has really taught us that we cannot operate alone. We have to operate together in groups, and that is the way in which we will be more prepared. So this multidisciplinary science is absolutely critical to solving big problems. Yeah.
Mm-hmm. As is the diversity of ideas. And, it can be great when institutions are, putting quotas in place, encouraging more women to get into STEM. But as someone points out, this can sometimes cause further harm and start sort of that narrative of, that woman's only there to fill a quota. So how can we avoid that response? And I'm going to merge it with another question. How important is it to employ people on merit instead of gender? So Kim-Anh, you kind of have a little bit of experience with this specifically. What are your thoughts?
I think the comment of fulfilling a quota, I think it's really unfair. And I would say it's probably coming from a male. So I would say if you're a woman and, you've been hired, whether it's a woman-only position or not, just, embrace it. Just take it. Because, as women, we've been really penalized for so many years. So, yeah, you take me because I'm a woman, but you also take me because I'm a very good scientist, and I'm just going to own it, and I don't really care. I think we should have this sense of entitlement as women now. And yes, quota can be harmful. But yeah, we need to take into account the history behind us and say, well, at some stage we have to change. And so we have to do it in a very drastic way. It's going to be very painful for half of the population, but it's going to be beneficial for the other half. So we do it, it's going to be, harmed. But then after that, you would hope that we have this equity in place.
Yeah, that's what we
Totally agree with Kim-Anh there. If we do, there's been so much inequality for so long that if we do not do something now, it's just going to drag on and on and on forever. So quotas, although yes, they can be harmful, and sometimes I even think, did I only get that grant because I scraped in because they, tried to make it 50-50 and, I got, but I think this is ridiculous. I know that I'm a great scientist. I know that what I do is just as good as, these other people. We have to introduce the quotas so that we can make the change. It won't always have to be like this, as Kim-Anh says. So we need to get through a period of some people feeling uncomfortable or not liking it. But when we do reach equality, then it won't even be an issue, and we won't be talking about it at some point.
Yeah, and you could also ask your question back, why didn't I get that grant last year? Was it because I was a woman? Well, maybe. So I think as a person who receives the grant or the award, you should always think, well, it's based on merit. I really,
yes. And merit can be judged in lots of different ways by different people. So if you have 5 people reading this grant, they might think of merit as one thing, and then 5 other people might think of it as another. So someone might look at your grant and say, well, they've had, 2 children in the last 4 years and they've published this many papers. It's only 50% of the amount of papers that this man has published in the last 5 years, but he probably didn't have to, go on maternity leave and spend as much time with the children at home and all of that sort of stuff. So you start thinking, is the merit the 50 papers, or is it the 25 papers or the 20 papers that the woman has had plus maternity leave? It just becomes really blurred. I think you really need to, think about people's careers on the whole and what they've achieved relative to opportunity.
Yeah, which is really why we need to shift away from publish or perish, because it's not all about publications. It's about everything that you're doing in your whole life. Someone's asking whether there are any attributes that you've come across either in yourselves or perhaps in the people that you've been working around that have a positive impact on their science and their work, or perhaps even the work environment. So this is particularly for students who are going into science. Are there any sort of attributes or things that you'd recommend they sort of pick up?
Resilience. Oh, I think that's one of the biggest things you have to have in science, and adaptability, and passion. I would say if you do not have a passion for what you're doing, it's just not going to work out. I think the most important thing is that you choose something, you love it, and you keep doing that. And if you're not, the great thing about science is you can go and do honours in one lab and you can say, yeah, I really enjoyed that experience, but it's not 100% what I wanted to do. And then that lab should be 100% supportive in helping you find a PhD in a field that you want to work in, or maybe go and work in industry, in something that you might really enjoy, or go and do a medical degree. Where is your passion? Follow that passion. But you do have to be quite resilient in science. And I think that's a great thing to have, and to be adaptable. Things are not always going to work the first time. Things are not always going to turn out. You're going to get turned down for more grants than you are going to win grants, or rejected from more journals than you are going to be accepted, all of those kinds of things. So, those are important, I would say, for me.
I have a T-shirt that says "Pipette, cry, repeat." Resilience, as you say, Jack, so important.
The passion is really important, and also being strategic. I think you need to, when you start to think about, long term, what you want to do, you have to think about, what are your career prospects, or what you can do next, and what's going to help you to go next. I think the environment is really important. I know that sometimes some students feel like they should join a lab where the group leader is extremely well known in their field, but it could also be like just an industry of postdocs there, or where actually it's not a supportive environment. And so sometimes it might be better to actually go to a lab that is not as well known, but do extremely good research. But doesn't publish every day in Nature, but because you may have a much more supportive environment also to flourish and, be a more well-rounded scientist than working in silo, working on your Nature paper on your
own. Just jumping back to the previous question, Frances Saparovic, who's another amazing woman in STEM, has just made a comment that I'd like to share to everyone. It's not just maternity and caring duties, but also other commitments, sometimes even work commitments, that often impact more on women. Like, if you think about it, we're hosting this Women in Biomed series, and I'm asking, the Convergent Science Network is asking two women to take time out of their day to come along. And I know, Kim-Anh, you participated in Homeward Bound as well, an incredible program, but takes a lot of time, right? So, thanks for bringing that up, Frances.
Yes, so Frances is actually part of my Homeward Bound cohort, so I know her really well. And yes, sometimes it can be very frustrating because you're invited to a panel and you're thinking, is it because I'm the only woman who is not white? That's why. Is it why you're inviting me to that panel? And sometimes it can be very frustrating. And sometimes you have to say no and say, look, find somewhere else, hire more women.
So I just want to end, because I know we're coming towards time, but end on a final question, because I know that there are students on the call as well who are looking to start off their careers in biomedicine. In 30 seconds or under, what is the one piece of advice that you'd give to young people who are sort of more at the beginning of their research career, wanting to make it in research? Maybe Jack, we'll start with you.
Yeah, I would say get into a lab and get some experience at the undergraduate level. Go and do one of those undergraduate projects and see how much you love it. And that is going to give you an idea of how passionate you are about scientific research. And if you don't like it, please go and do something else, because, it's a tough work environment. And I really just think everyone deserves to be happy and to follow their passion. So I would say get in there and give it a try.
Thank you. Kim-Anh?
I would say listen to your gut. Listen to your gut more than listen to what everybody else tells you, because, there's so many barriers, internal barriers that we have about, oh, I shouldn't probably do that. Or, some people say it might be a bad idea, or, you think I'm not good enough at this. I would say don't listen to that. Just listen to your passion.
Definitely.
Thank you. That's such a lovely positive note to end on as well. So thank you very much, Kim-Anh and Jack, for sharing your thoughts, sharing your experiences and answering those questions. Certainly, I think when thinking about diversity and inclusion in STEM, it begins with conversations like these and really considering the experience of others. And I think it's an amazing thing to have a series like this, because I think we really need to support each other as well, especially as women. So everyone, I know we can't see you, but thank you very much to Professor Kim-Anh Lekau and Associate Professor Jack Pearson. I'm going to give you a clap.
Thank you.
Hopefully everyone else is, echoing my sentiment of clapping. Just a reminder that you can continue the conversation on Twitter with that hashtag Women in Biomed, because, I think both of you have touched on such amazing points, and I think, this is only the beginning, right, of the discussion. Just to everyone on the call as well, you'll receive an email this afternoon to complete an anonymous survey. We would really appreciate your feedback as we plan for future Women in Biomed events. So thank you very much, Kim-Anh and Jack. Thank you to Lamont and Colin behind the scenes as well, and all the people who make this possible. So thanks for coming along, everyone. Enjoy the rest of your day.
Thank you.
Thanks, Katrina.